Okay, let's start. So today we have a task to write some classes. So we have class math operations. Let's create a project. So let's say project. Sorry for that. So we know that the class name should be math operations. So we start creating class math operations. Math operations. Yes, I forgot. So we should first create a class here. New class. Class name file name should match the name of the class, so math operations. Here we go. Public class math operations. And we're good. And so we want this class to have methods like add, subtract, multiply, and divide. So let's add them. But first let's create the main function, since it's an entry point. Public static void main. Oops. Now, so we want method add that returns sum of two numbers. So let's create it. Public static int sum integer x integer y. So I created this method using the static keyword because I want to directly call that method from the main function, so I give it a static keyword so that I wouldn't need to create an object of that class. And here we want to return the sum of so this method it returns integer. Here is the name of the method sum. It accepts two parameters, x and y, and we want to return the sum of these parameters. So let's go and check this. Let's say we have sum and we call this method. So we say 2 and 3. Now we want to print out this sum of, no, let's say 2 plus 3 is equal to sum. Now let's run this. You can see the result is 5, so it's correct. Let's go on. Now we use static integer. Now let's say we need a subtraction. And let's say we pass 2 parameters. And return the subtraction. Let's go and check this. Let me use the same variable. Say result. Little misspell here. Result. Let's keep the parameters, let's keep the values, the arguments the same. So 2 minus 3, let's call subtract. Run the function. 2 minus 3 is minus 1, so correct. Now let's write static integer multiplication. So integer x, integer y as parameters, multiplication, and the same logic here, x times y. So the return keyword here it means that this is the return value. So first it will execute x times y. So what is x and y? These are the parameters that we pass from our function, from the main function. So let's call it multiplication. 2 times 3. So when we pass, so we have a variable here that is within the main function, integer result. So the result variable will keep the value of this called method. So we call the multiplication method and pass the parameters 2 and 3, and then we come to this line, and this line is executed. So it sees that x is 2 and y is 3. Then it executes the math operation. So 2 times 3 6. Then the return keyword here, it returns the result of the operation to the calling code. So it returns to the result number 6, and so it prints here 6. So 2 times 3. It's gonna run this. So the result is 6. Correct. And now let me do the division. Let me write the method for division. So as we know, when we divide two numbers, the result is not always a whole number, so the return value will be double here. Divide. It accepts two parameters, two values. It accepts two arguments and returns the division x divided by y. For higher precision, we can use casting here, just to make sure that everything is correct here. And now let's go and run this. Divide, let's say 3 by 2. 3 divided by 2 is equal to what? We have here a mistake. Yes, so the type of the result should not be an integer, it should be double. Now we can run this. So we get the result 1.5. Okay. Now we'll write a method for finding the maximum of two numbers. So find max. Let's go and get that. Let's go and write it. So public static. So the return value will be an integer. Find max is the name of our method. So let's say we pass here a and b. Let me move this. Okay, so find max. Let's say we have, let's directly write a return. So in order to find a maximum of two numbers, we can use the math library. The method max from the math library. So let's go and use that. Math.max. And here we pass here our a and b. So okay, let's create a variable result and find max. Let's say we have 32 and minus 14. Let's print that. Result. Okay. So 32 is greater than minus 14, obvious. So it prints 32, it works correctly. Let's go to the next one. So the difference between x and y. Alright, public static. So the return value will be an integer. The name of the method difference. Accepts parameters x and y and returns the difference. Okay, so let's use the absolute method from the math function, math dot absolute, and we will subtract x from y. X from y. I will explain this in a minute. Result. Okay. Turn the result x minus y. So why did we use the absolute method here? Because for example, if we pass 2 and 3 here, 2 for x and 3 for y, then 2 minus 3 will be minus 1, and minus 1 is then within the absolute function will turn into a 1. So the difference between 2 and 3 is 1. So that's the logic behind this program. Let's run this program. Let's say the difference. We can also use 32 and minus 14 for this. Let's see the result. The difference between 32 and minus 14 is 46. Is it correct? Yes. Absolutely. Now, let's create a method for calculating the area and the perimeter of the square. We need method square area and square perimeter that accepts parameter side. Okay, let's go and do that. Public static. So the return value for the area will be an integer. So square area, integer side, and return. So the formula for square area is side squared, just side times side. Now let's go and run this. So let's say we call square area. Let's give the different arguments. So if we want to find the square area of 3, let me write here. The square area of 3 is of course 9. Now square perimeter, public static, the return type of this method will be an integer. Square perimeter, integer side, it accepts the parameter side and returns the formula for square perimeter is 4 times side, so it's 4 times side. Let's just see the result. Square perimeter of 5, let's say. Five times 4 is 20, so correct. Let's move on. Now we have a method convert seconds to minutes that accepts parameter seconds. So again we start from public static return. The return type of this method is integer, so the name of our method is convert seconds to minutes. Convert seconds to minutes. It accepts parameter side and returns minutes. So in order to get minutes from seconds, we need to divide side by, this is not side by the way, these are seconds, so sorry for that. We need to divide seconds by 60, then we will obtain minutes. Let's go and see. So let's convert seconds to minutes. Let's say we have 3600 seconds. These are 60 minutes. So let's go and check this. Oh, we have a problem here. Extra brackets. Let's go and run this again. And now we're good. So 3600 seconds in 60 minutes. So we're good. Now, the next task. The average speed method. Let's go and create this. Okay, public, again, static. The return value of this method will be double. The name, average speed, and it accepts 2 parameters. This is time and distance. So distance and double time. And we return the average speed is the distance per time. Distance per time. Now let's see. System out. average speed. Let's say 50 for the distance, and time let's say 30. Let's see the result. 1.6. Okay, this is not obvious. Let me try and change this. So the average speed, the average speed of 60 kilometers and let's say 30 not 30, let's say 3 hours is equal to, let me create a result variable here, result average speed 50, let's change it to 60, so 60 kilometers per 3 hours, semicolon of course, here kilometers per hour. We forgot the result plus, this is not integer, of course this is double. Let's go and check. So we got the average speed of 60 kilometers and 3 hours, 20 kilometers per hour. Okay, let's go to the next method. Let's try other values. So let's say we have 130, let's say 34, 130, 34, let's see the average speed here, 3.8 kilometers per hour, given that the distance is 130 kilometers and the time is 34 hours. Okay, good. Now we want to write a method find hypotenuse that accepts two parameters, double with a data type of double A and double B. Okay, we can use the math square method for this. Let's go and write the method. Public static, so the hypotenuse, the return value will be a double find hypotenuse. It accepts two parameters, A and B. Good. And now return value will be, can use the method math sqrt. Now, as we know, the formula for the hypotenuse is a squared plus b squared under the square root, so this is a times a plus b times b. Let's make it nicer. semicolon. Okay. Now we can go and check this. Okay. System out. Find hypotenuse. Let's pass 3, 4. So it should return as 5. Let me make it nicer. Sorry. So the hypotenuse is 3 and 4 is equal to this value. Okay, it should be 5. Let's check. Yes. 3, 4, 5. Correct. Now we'll write a method that finds the length of the circumference of a circle. So let's go and write this. Again, public static. The return value will be integer. No, it's gonna be double. Double. Circle circumference. Circumference. Circle circumference. And the parameters. Double radius. So this method accepts the parameter radius and returns the length of the circumference, which we can find from the formula 2 pi times radius. So this is 2 times pi we can obtain from the math library with method pi times the radius, semicolon. Good. Now let's see what we got here. System out. Circle circumference. Circle. Okay, let me make it clear here. So the circumference of a circle with the radius of, let's say, 6 is, now we call our method circle circumference and pass the argument 6. Let's go and check this. The circumference of a circle with radius of 6 is 37.699. Good. Okay. Now. Okay, let's try with another value. Let's say we get 36. 36. Let's go and check this. 226. Let's give it a negative value. Let's give it a 0. So if we have 0, then the circumference will also be 0. Yes, correct. But we have a mistake here. The circumference cannot be negative, so I will wrap around this whole expression into an absolute method. Now we're good. So if we say it's negative 34, no, it's correct. Correct. Okay. The next method, we should calculate the percentage here that accepts total and part as parameters. So let's go and write this. Let's go and write the methods outside the main function. So it's again public static that returns the double data type, the double value, the return value is double. Calculate percentage, accepts double part and double total. We need another bracket. We need curly braces. So curly braces indicate they mark the beginning and end of the program, of the code. So this is the beginning and ending of the method calculate percentage here. So then so it returns the percentage. To find the percentage we can use this formula. Total is part over total divided by total times 100. So part over total times 100. Good. Let's go and check this. System out. Print ln. So let's say the percentage of points out of 150 is, now we call our method here, so calculate percentage, and we pass 30 and 150. Also we can add here percent. Let's go and check this. So 30 points out of 150 is 20%. Let's say 30 out of 100. 100, then it should be 30. Let's go and run this. Exactly. So the percentage of 30 points out of 100 is 30%, correct. Now, the last method. So we will create a method for converting the degrees of Celsius to Fahrenheit and the other way around. Let's go and write this. Let's go clear this. Clear here. So again, public static. So the return value will be double. So Celsius to Fahrenheit. Let's start from Celsius to Fahrenheit. Fahrenheit, Celsius, Celsius to Fahrenheit. So we pass, of course, Celsius. Let's mark it like C. And it returns Fahrenheit. To calculate, we have a formula here, C times 9/5 plus 32. So C times 9/5. So to avoid the mistakes here, we will use a floating point numbers like 9.0 and 5.0. 9/5 plus 32. Okay. Let's go and check. Let's say we have a result. Result Celsius to Fahrenheit. Let's say we have 30 Celsius. Let's go and check this. So 30 Celsius is how much Fahrenheit? Is a result Fahrenheit. Let's go and run this. So 30 degrees Celsius is 86 degrees of Fahrenheit. Now we can check this by writing the next method, where we convert the Fahrenheit into Celsius. So again, public static. The return value is double. Now Fahrenheit to Celsius. Fahrenheit to Celsius. So it accepts Fahrenheit and returns the value in degrees Celsius. So the formula for this is Fahrenheit times, to be more precise, Fahrenheit minus 32. Let's take it into brackets, curly brackets. Fahrenheit minus 32 times 5/9, 5.0 over 9.0. Okay. Fahrenheit minus 32, is it correct? Yes. Okay. Now let's say we have another double, result number 2, which is Fahrenheit to Celsius. Okay, let's say 86. So we want to check the previous result. So 86 Fahrenheit is how much Celsius? We forgot the result here. This much Celsius. Let's go and run this. We should get this 30, 86, exactly. So 86 Fahrenheit is 30 degrees, and 30 degrees Celsius is 86 Fahrenheit. Correct. Okay, that is the last question. Thank you for watching.